Hi. This tutorial will be going over C#, so we'll be continuing C# in the playlist. So this video is on logical operators. So I'm not sure if we talked about these. We may have used them. I may have used them here and there. But basically, let's just do some notes down here. Let's actually just, whoops, open up a star comment. What the heck happened there? Okay. Not sure what happened there. Where are we? Stop. Okay. Okay, so the logical AND operator and the logical OR operator or just basically just the double symbols allow you to connect multiple Boolean expressions to create a compound expression. So the logical NOT operator, so the logic, let's just talk about what they are. So this is the AND operator, OR operator, and the NOT operator. So basically, you can create compound expressions, and the logical NOT operator reverses the truth of a Boolean expression. So basically just makes false true and true false. So you can use these in conditional statements. Hopefully you guys can see that properly. This is AND. Logical operators. So this is AND. So this is the AND, logical OR, and logical NOT. Pretty much the same as every other language, except for Python actually pretty much just spells them out in English, but otherwise in C# and most of other languages they have them like this. So for the AND, both sub-expressions must be true for the compound expression to be true. So an example of this, like if val1 and val2 equal to 5, then proceed into the statement. For example, the same example here, we can have if val1 or val2 are equal to 5. So then we can continue into the statement. So in this case, both sub-expressions for an AND have to be true for this whole statement to be true. In this case, only one statement has to be true for this statement to be true. Sub-expression for the statement to be true. Only one sub-expression has to be true, so it's just going to check the first one. If the first one's true, the compiler doesn't check the second one to save time and memory. So the first one only has to be true. If the first one is not true, it's going to check this one. If val2 is then true, then the statement will be true. If none of them are true, it'll be false. So at least one has to be false. You can see C, it's exactly the same C programming. I have an in-depth logical operators tutorial on that. I don't think we really need to do the truth table here. Basically that's it. Here you can say like if, so you can have a if basically not val1 is equal to 4. So if it's equal to 5, So if not val1 is equal or points to 4, then in that case, if val's, let's just say val is 5 or points to 5, then this statement will be true because it's not equal to 4. So anything else, if val1 is equal to anything other than 4, this statement will be true. Okay, so that's pretty much it. So the logical OR operator connects two Boolean expressions into one compound expression. One or both sub-expressions must be true for the compound expression to be true. It only needs one to be true, so the logical NOT operator is a unary operator, meaning it only works with one operand. The operand must be a Boolean expression. The NOT operator reverses the truth of its expression if it is applied to an expression that is true. The operator returns false. If it is applied to an expression that is false, the operator returns true. So we could do just a few more examples here. So we could have like if temp, let's just go with val, if val is less than 20 and val is let's go with val 2 is greater than 50, then we can say message box dot show was in the zone or whatever, or in the was in the zone, whatever you want. So that's fine. So then we can do an OR. I don't think we need to do the truth table. Actually, maybe we could. This is going to take longer to do the truth table though. You don't really need to because both of them have to be true, and the rest of them will be false otherwise. So if one's true and one's false, if one's false and one's true and one's false and one's false, those will all be false. The only time an AND will be true is if the first sub-expression and the second sub-expression are true, which will make it true. You guys will probably don't understand what I'm saying if you. I'll just do the truth table. So it's true and false would be false. False and true would be true. Sorry, false. False and false would be true. True and true would be true. That's the truth table for the AND. So this is the truth table. Excuse me. You will get tested on this for sure. If you're taking this in a university or high school class, most likely university, you'll get tested on this for sure. Sometimes there's other ones which we'll talk about. Okay, so this should be fine for AND. We'll talk about OR now. So do an example for that. So if val, what do we do? Val 1, val 2. If val so if val is less than 100 or val 2 is hopefully this will be great, we'll be fine. We'll just go with some random number. So if val is less than 100 and val2 is greater than some large number, then we'll say, okay, well, message box dot show, then we'll say in the range, whatever. So we'll just do the truth table for that then. Which will be so true and, or sorry, true or false will be true because one of them is true. False or true will be true because one of them is true. False or false will be obviously false because none of them are true. And if both of them are true, true or true will be true. Okay, so that'll be it. Okay, I think it's my notes skipped the not. That's fine. We'll talk about it later on. Actually, yeah, we might see it again. So short circuit evaluation, both the and or operators perform short circuit evaluation. Basically, as I mentioned, if the first sub-expression is like true in an or, then you don't check the second one. So for an and, if the expression on the left side of the and operator is false, the expression on the right side is not checked to save time, memory, and all that. Because the compound expression is false, if only one of the sub-expressions is false, it would waste CPU time, memory, resources on all that. This is called short circuit evaluation. So the same thing applies. So the same short circuit, well, slightly different, but the same concept of short circuit evaluation applies to the OR operator. If the expression on the left side of the OR operator is true, the expression on the right side is not checked. Once again, it saves CPU time, memory, resources, and all that. Power consumption, perhaps, which will be a minor change, but yeah, that's pretty much it. Okay, so let's just do now the not operator. So let's do that here. So the logical, sorry, did I say not? So it's logical not. So we'll do an example. Excuse me, so if not val is greater than 100, whatever, 1000, then we'll have, so basically if val is less than 1000, this is true because it's saying, okay, well if val is greater than 1000, this is true, but then we're saying, okay, we want a logical not attached to that, which would flip this sign. So this statement is equivalent to if val is less than 1000, if that makes sense. Because the not flips whatever logical operator is being compared, so it makes this false, which would mean it would flip, basically. It's kind of confusing to understand. But this is equivalent to, or equal to this. So in this case, we just say, okay, well, in that case, if it's true, you want to do something, message box.show, whatever you want. Truth table for the not is a little bit confusing, so we'll just talk about it here. So truth table, sorry, I just think I hit the mic by accident, apologize for that. So truth table, not. So if it's not true, then it's false, and if it's not false, then it's true. That's it. Alright, so let's continue on with that. So precedence, so this is a tricky one. So precedence of the logical operators, which kind of means like which one has the highest priority in programming. So we mentioned earlier that the not operator has the highest precedence, so this is an important fact. So not operator has the highest precedence of the logical operators. You'll see that word around more. Precedence applies to relational operators and perhaps bitwise operators. There could be a bunch of them, which can get confusing. So operators, you will get tested on those, by the way, always. But operator has, so it's pretty much the concept that's you have to remember that's tricky. You definitely have to study those, but the not operator has the highest precedence of the logical operators. Actually, I might have said that wrong. The not operator has the highest precedence. So we mentioned earlier that the not operator, I believe I mentioned it, hopefully I did. If I didn't, so basically the not operator has higher precedence than the relational operators, so I should change that to this. Relational, so not logical. In that case, that's confusing because maybe logical would be, this would be after and or, because and or would have to go first and then not would go last. If it doesn't go last, it won't be able to flip the expression from true to false. But in this case, it has the highest precedence of the relational operators. But basically, this can get confusing. So some more notes here. Is it tagging those stars automatically? Okay, so we have, so basically the and or operators have lower precedence so the and or operators have lower precedence than the relational operators. Example, so we say like, so score is, let's just say val is greater than some number. So if val is greater than that integer 701, or val2 is greater than an integer, some large number like 10,000. When this expression is evaluated, the greater than operator works first. And then the or operator works after. Basically, so what's happening first is it's going to check if val is greater than 7,001 and val2 is greater than 1,000, and then check the or after. That's what precedence means. It's basically just priority. So how the compiler is going to actually evaluate the expression, which is it's an important topic, because obviously that can get mixed up if it does it the other way around. So you can use brackets or parentheses to make this more readable for yourself, or to help you evaluate it easier when you read it. The compiler will know though, so just you can use them if you like. It's up to you. Alright, so let's just see what else we have to talk about. Okay, So quite a bit of stuff. Okay, so we have, so you can check a numeric range with logical operators. You can say, if val is greater than 30 and val is less than like 100, then it's some value between there, right? Then you can proceed into doing whatever you need to do. That's how you check a numerical range with logical operators. You can also throw a less than or equal, a greater than or equal in here, or less than or equal to include 30 and 100 versus 29 and 31 and 99. So you can check a range, you can check if it's outside the range. Obviously you just need to play around with whatever you're trying to do. That's just the best way to do it. Just trial and error it, or just try to do something. If you don't realize that didn't work, try something else. Something should work once you think about it, which can be difficult at first, but that's pretty much how coding works. So you have to think about it. If something doesn't work, you have to try something else, which can be kind of the hard part of coding, because you want to make sure that in the end you're doing the right thing. But usually you'll have to come back and fix something if something didn't work and make it work, and that's pretty much how it works. Obviously it can be hard at first, but once you practice and get the right methods and theories correct, you can figure it out. You want to do it the most efficient. You want to make sure what you're doing is the most efficient way to do something. You don't want to make sure, pretty much I'll just leave it at that. It can be kind of like a stressful topic, but you want to try to do the best that you can, like the most efficient and fastest way, and that you're doing it correctly, so later on you don't have to wonder why it doesn't work, or why. If you want to do it the best way possible, like you want to make sure what you're doing is going to work in an effective and efficient way, and you don't want to do it in the wrong way. But like I said, that's what happens. That usually happens in app development, where you have to come back and fix something. But that happens, I guess. It's normal. The most experienced programmer will know how to avoid those things, obviously. But it takes time, I guess, to understand that. So obviously you can check a number is outside of the range. I don't really have to tell you guys that. You could just kind of just flip them, right? Oh yes, okay, maybe someone might be confused, so you just say, okay, well, if val is less than or equal to 30 and val is greater than or equal to 100, then it's outside of the range. It's not going to be between 30 and 100 where before it was. So you have to be careful with this. Sometimes you may be looking for something inside the range when you're actually looking for something outside the range. So we could just leave it at that. Just pretty normal stuff here. There is a little GUI app on this, but we pretty much went through that. We don't really need to waste time making that. Actually, so that's pretty much it. In the next video, we'll be going over bool variables and flags, so another type we'll talk about, and we'll do another lab. So thanks for watching, guys. If you guys like the video, you guys can like and subscribe to the channel to support the channel. I would appreciate it. So see you guys next time in the next video, hopefully. Take care. I'll see you guys next time. Take care.